All right, I also want to look at with radical functions, square root, cube root functions that we've been talking about. How can we, again, look at a graph and write the equation for that? Kind of just do the backwards or reverse engineer sort of what we just did. We took an equation, we graphed it. Now here is what a graph looks like. Can we figure out the equation? So let's take a look at this. The way that I would approach these problems is to first, gather some clues, right? So if you look at this function, this certainly looks like a cube root function. So I would think about, what's the general shape of this? The parent function of this is, cube root. This is a cube root function, right? With a cube root function, we also want to think about the shifts that or how the shape has changed. Did it shift left or right? Was there any vertical stretch involved? And so we know that with a cube root function, one of the key points was the middle, right, or what we call the inflection point, right? And you can see that this point is right here on this graph. Typically, or with a parent function, it's always centered right on the origin. It's right at 0, 0. So basically, it was at 0, 0, and it went 1, 2, 3 to the left, and it went down 4. Right? So just looking at that, we can see what the shift looks to be about, right? So I'm going to write that down. Shift 3 left, and shift 4 down, right? The last thing that we can look at is the stretch, or the a value here. So if we think about the parent function, all right, the parent function for this is that, if I have root x and I plug in, let's say, 1, right, I get 1, right? So this graph right here, 1, I get 1, and it would start to go like this. And -1 would go to -1, it would start to go like this. Well, think about what the stretch is of the function that we have, right? So we have this function right here, right? And if we look at its sort of, one spot to the right of it, it doesn't go up 1. You can see it actually goes up 2. So to me, this looks like a vertical stretch of 2, right? It's being stretched out by a factor of 2. So I'm going to write that down. This looks like a vertical stretch of 2. Which really means my a value is going to be 2. Okay, so look at the graph, kind of gather the clues that you have here, and then we just put it together. So we're going to write a function. We're going to call this g of x. Okay, I know that there is a shift to the left 3, so I know this is going to be a cube root of, if I'm going to go to the left, I'm going to say this is x, and it's going to the left. So I'm going to say plus 3. Okay, that'd be a shift left 3. It goes down 4, so I know that at the end here we're going to say -4. It's kind of like your k value. And then the a value, the stretch value, is times 2, so that this a value here is going to be, a times 2. So that's what we're trying to do, is construct a function that kind of matches the shape of a graph, right? And so that's what we just did. We look at that, we see where it shifted. It went left 3, down 4, stretched it by 2, and we can fill in these parameters into or extend that parent function of just cube root x. We can add those in.